This video introduces polynomials. So a polynomial of degree n is something that looks like this. So an x to the n power plus an minus 1 x to the n minus 1 power plus a bunch of terms until I get down to a1 x to the first plus a0. And x is a variable, x is an unknown, but these an minus 1 things are real numbers. So that's what a polynomial is. Let's see some examples. So x squared plus 3x plus 2 is a polynomial. Here, n is equal to 2, so my degree is 2. It's the highest power of x you see. And I have, maybe I can write 1x squared to show you that the first term has this coefficient equal to 1. 3x plus 2. Here's another polynomial. How about 9x to the 6th plus 3x plus pi minus x to the 7th. So I kind of tricked you on this one. You thought it was going to be degree 6, but it's actually degree 7 because at the end I decided to put an x to the 7th power. That's the highest exponent you see, so this is a degree 7 polynomial. So in a polynomial, you're allowed to multiply powers of x together and add them. You can do operations with polynomials. You can multiply them, you can factor them, you can simplify them. So I'd like to do a couple of examples of operations on polynomials. You probably have seen a few of these in your mathematical past. So let's remind ourselves. How about we multiply x squared plus 1 times 4x plus 2. So we have to distribute when we multiply polynomials. Some people call it the FOIL method or expanding. However you want to do it, make sure you do it right. I don't really care the method. But you have to multiply x squared times 4x. If you multiply x squared times 4x, you're going to get 4x to the third. Then I'm going to multiply x squared times 2 to get 2x squared. Then I'm going to multiply 1 times 4x to get 4x. And then 1 times 2 to get 2. So in general, when you multiply two polynomials that have two terms, you'll get a polynomial with 4 terms. Let's do another example. How about if I multiply something that looks like x plus a times x minus a. So if you multiply, you get x times x, which is x squared, minus x times a, so minus ax, plus ax, minus a squared. So you get 4 terms, but this time, these middle 2 terms cancel one another out, and I get x squared minus a squared. So this is the famous difference of squares factoring trick. Difference of squares, because I have x squared minus a squared, and sometimes it's just convenient to remember that this can be expressed as a multiplication using these 2 terms. Let's do a couple of factoring examples. So let's factor x times x squared minus 5 plus 9 times x squared minus 5. So factoring means to undo this multiplication process, take an expanded form or partially expanded polynomial and write it as a product. So I notice that in this example, x squared minus 5 is in both terms. So I'll factor that out. I'll have an x squared minus 5 in front, and then what's left is an x plus 9. I could go one step further, and I could even notice I have a difference of squares here. I could write this as x plus square root of 5 times x minus square root of 5. That's my difference of squares. I have x squared, and my other square is the square root of 5 squared, so it's a little silly, but it works. And I still have times x plus 9. So that's an example of factoring. We'll do one more factoring example. How about factor 3x squared minus 16x plus 5. Now, if you factor this, I'm just going to skip ahead and show you what the answer is and then discuss how to get it. So I'm going to say that this is 3x minus 1 times x minus 5. You could check that you have the right answer, because if you multiply this out, you're going to get 3x squared. You could see that the constant term, the term with the no power of x in it, would be negative 1 times negative 5, or 5. And then you could verify that the other two terms that you get from expanding this will combine and give you negative 16x. So that's how you can factor this polynomial. The way I got it was essentially just guessing and checking. Essentially just guessing and checking which combinations of 3, negative 1, 5, and 1 combine to give me this polynomial. You can also get this factorization using the quadratic equation, which we're going to discuss in a future video. Okay, let's finish with one example of simplifying. So let's simplify the following expression. So I have 1 plus 1 over x squared minus 1 minus 1 over x squared. So to simplify this, I'm going to use the same kind of distributing of the multiplication of polynomials that I had in these two examples up here. I'm going to write this as 1 plus 1 over x times 1 plus 1 over x minus 1 minus 1 over x times 1 minus 1 over x. So I expanded it out a little bit just to help me see what's happening. Then I'm going to multiply everything out. I'm going to do 1 times 1, 1 times 1 over x. So I get 1 plus 1 over x. And then I do 1 over x times 1, so another 1 over x, and then plus 1 over x squared. I see a lot of negative sign errors when I look at student work, and that could be avoided by sometimes making sure you keep parentheses in place. So if I put my parentheses in place and I multiply, I get 1 minus 1 over x. I get another minus 1 over x, and then I get plus 1 over x squared. So let's see what things simplify to. Here I have 1 minus 1, so the 1's cancel. I have positive 1 over x squared minus 1 over x squared, so this term and this term cancel. These will combine and give me 2 over x, and this will be actually a plus 2 over x, so I believe the whole thing simplifies to 4 over x. Okay, so that's a brief introduction to what a polynomial is and what we could do with them. We could add two polynomials together, we can multiply two polynomials together, we could factor, simplify, and do operations like that. Okay, wonderful.